Hello everyone and welcome to another SuncatByte. Today's SuncatByte is going to be a continuation on arrays and just a couple more topics and an example on using arrays. So first off, when we're accessing arrays, in order to access the elements of an array to fill an array or to print out values from an array, there's one very useful construct or loop that we've looked at so far, and it's a for loop. So for loops are an efficient method for traversing arrays. So then when we do this, the index of the loop is used not only as a counter, for the for loop, but also as an index value for the array. So an example, let's think back to our phone bill example that we previously looked at. So one of the key things to think about here is we use for loops when we know how many times we want to loop through something. In an array, we know how big it is. So that's why these two things go together quite well. So here's an example. So here's the index I in this example. It's initialized to 0, right? So we say I equals 0, I less than 12 plus I. That gives us 0 to 11 as our values for I. The array has 0 to 11 values, right? Because there's 12. And then when we access the array inside of this loop, we have cin phone bills I. So we're telling the user enter bill for month, 0 plus 1, which is January, and then cin phone bills. So as we loop through the array, we use our for loop to go ahead and put values in the array. And we get values from 0 to 11. In this case, the first time they put 45.14, then 45.14 again for February, 47.72 for March, all the way down to 48.99 for December. Say we wanted to take that a step further and calculate an average. Well, fair enough. First part is going to be the same, right? As far as I equals 0, I less than 12 plus I. But in this case, we're going to assume that we now already have these values read in up here. So then we're going to say sum equals 0.0 for I equals 0, I less than 12 plus I. Sum equals sum plus phone bills. So initially, there's nothing in sum. It's set to 0, and then it gets phone bills I. First time through, phone bills I is going to be phone bills 0, so 45.14. So then we'll have 45.14 in there. Then we're going to increment. We're going to loop through again. Now we're going to have I equals 1, so 45.14 plus 45.14, which would be what, 90.28? And then we just keep going from there. So first thing to realize there is, our first thing we talked about now is the for loops and how we can use those with arrays. So now there's another thing that we need to take into account when we're thinking about arrays, something that's very important. So C++ doesn't do, or does not do any type of array boundary checking, which basically means it doesn't check to see that you haven't gone outside of the bounds of your array or the number of elements in an array. Okay, so the program doesn't warn you or stop the program if a statement causes the program to access an array element that is not legally declared. So this is an out-of-bounds array, is what this would be known as, and it can cause C++ to trash your data or crash your program. So it crashes your program, that's a runtime error. You won't see anything when you're compiling. It'll happen as you run your program. So there is a case where the program performs a portion of the code where there's actually data. So when you get that weird data, it's actually when there's already something in memory. So an example of this we can look at in this graphic here. Say we have this, where this is going to be an actual crash. So C++ doesn't do any array boundary checking, right? As we looked at here. So say we have this example where we have low, mid, high. These arrays, it has these values, right? So for I equals 0, I less than or equal to 4, here's the problem. Because if we think about it, that's going to give us 5 different array elements, 0, 1, 2, 3, and 4. But these only have 0, 1, 2, 3. So if we try to access these, we're going to actually start outputting things, and you're going to get 81505. You're going to start getting weird output on these statements here, right? And then here as well, you're going to output this next one, but on the end, there's nothing there. So then you're going to get that crash. So you kind of have two different issues here. One is when you go out of bounds, there's data here, so you're printing data you didn't mean to, here and here. The other one is there's no data there, so then you're going to have an issue. It's going to crash. It's going to give us what we call a runtime error. So we'll actually look at an example of this shortly in C++. But one more thing I want to talk about, and some of you might have caught on with already because we used vectors before, is vectors versus arrays. Okay, so what are the differences? Well, pretty simple, right? In vectors, a C++ vector allows a programmer to add elements into a vector without limitation. Vector can grow or shrink in size. Arrays are predefined, right? So when you declare an array, that's predefined. So there's one difference. Here, the language sets up the requested memory that is legal memory in which you have to work. So for arrays. One other thing that I would say is, if you're looking at other programming languages, are common in other languages, vectors are not. So that's another big difference between them. So then we have this question. Should I use vectors or arrays? So answer depends on the program that you're writing. If you know exactly how many items you'll have in a group, such as the yearly phone bill program, which we've been looking at, then go ahead and use an array. If you need your group to grow as a program runs, that is, you're not exactly sure how many items you'll be working with, vectors are good to use. And then the other thing is if you're considering doing a bunch of other programming languages, you might want to just start getting used to using arrays now. That's a personal preference for you, but like I said, arrays will exist in other languages and not in C++. So let's take a look at an example now. Our mid, high, low example. So here, our high, mid, low, you can see all we have is IOStream included. And then we have, for I equals 0, I less than equal 4, plus plus I. Low is I, right? Mid, high. And then we're just doing some random number generation here, which we'll cover in another SuncatByte. But for the time being, just know that that's generating a random number. So, what's going to be the problem with this? Well, let's see. Is there any problem with compiling? No, compiles just fine. So the issue is going to be here. Out of bounds, right? Our arrays have a size of 4, and yet we're saying less than or equal to 4, which is going to be 0, 1, 2, 3, 4, 5. So as we run this program, we get a runtime error. So we get that runtime error because we actually went out of bounds on the array. How can we fix this? By taking this equal sign out and only accessing the correct elements of the array, or the number of elements in the array. Now it's going to run without any issues. So that's it for arrays at this point. Just keep that in mind. If you get that runtime error, that's going to be a key that you have to have a problem with the arrays. Also, if your arrays look like they have funny values in them, take a look at them and see if we get the other case that we were just looking at, which is where you have some overlap here. Maybe something like that, right? Low 4 would actually be 5. Mid 4 would be here. So that's it. If you have any questions, comments, or concerns, please let me know via the discussion board forum, email, or see you during office hours or lab time. Talk to you soon. Bye.